Welcome back to Bal Vigyan Bharati with Avilash Sarkar. Now we'll move to the problem number 45 in ratio and proportion, where this 45 consisted of small problem which are basically not very related to arithmetic kind of problem in ratio and proportion. Rather, it could be the algebraic kind. This is also a very common asked problem in exams. So this kind of problem has need some certain concept. So those I will discuss, and due to that I have taken this kind of problem. This is not very tough, but at least the way that has to be solved to be known to you. So that's why I have brought this for you. This may consist of small sum problem. So I will kept under one number, that is 45, and this will be given as the alphabetic A, B like kind of thing. So the first problem is problem A of 45. It says if A by B plus C, B by C plus A is equal to C by A plus B, this equation, then find the equivalent value of these fractions. So that means it says that if these are equal, then this must be equal to some value. So you have to find that value. Now this during discussion of the corollary, I have given this kind of example corollary where this is equal to some value for some condition. So that if these are equal, there I proved if A plus B plus C is not equal to 0, then A is equal to B is equal to C. Okay. So now we may arrive in some condition where we also will say that A plus B plus C is not equal to 0, because if that is equal to 0, this have a definite specific value, otherwise this has a different value. So now let me start with by solving, because here I will adopt a different method of solving that I have chosen while I am discussing the corollary, but this I will solve it in different way. So keep watch on that process also, and similarly follow this also. Okay. So now I am taking straightway this is equal to k, as because these are same, this denotes some fraction or ratio. So this ratio I am taking as k, say. Okay. Now if it is so, by equalizing this and this, what I will get? A is equal to k into B plus C. When I equalize this will be first equation. Similarly, other two I will get by equalizing the terms. C is equal to k into A plus B is equal to is third equation. Now what I will need, what I will do, I will add all these three. Okay. So let me, and I will add respective left hand side and right hand side. So if I add this, k is common, so the remaining term will come into a single bracket, and this term will be like this only. Now you will see here all the terms are coming twice. So instead of writing this, can I write twice of A plus twice of B and twice of C. Now 2 also is coming common, so I can further reduce it to this. So that means the multiplication factor A plus B plus C is coming on both sides along with the 2k. So now A plus B plus C, if not equal to 0, if it is 0, so that means 0 is equal to 0 doesn't have any equation remains. So if it is so, A is equal to B is equal to C, so then this constant either be 0, I can say this constant is either be 0, or if it is so, then a plus b is equal to minus c. Means I can change the term with respect to the other two terms. So a plus b can be written as minus c. So where that a plus b is coming here. So if I put this, so c by minus c, that has value is equal to minus 1. Now if a plus b plus c is equal to not equal to 0, this is the condition. If a plus b plus c is equal to 0, so k value is minus 1. This is one answer. Another answer, if a plus b plus c is not equal to 0, if it is not equal to 0, so that means this part cannot be 0. So now this, if it has to be equal, k must be equal to half. Now why? Because if I put k is equal to half, 2 into half is equal to give you 1. So then this equal to this. Only then this is possible. So other values, when k, this is not equal to 0, so k is, has to be this. Understood? So that means this equation is possible if a plus b plus c is not equal to 0, then k must be equal to half. This is the possibility. So there are two values of this ratio when the condition is not given specifically that a plus b plus c cannot be is equal to 0. So we can go with both the condition. So my answer will be, if a plus b plus c is equal to 0, k will be, we will declare it, k is the ratio of all three. Okay, so that is minus 1. And if k plus a plus b plus c not equal to 0, your k will be half. So this would be the two answer of you. Okay, so now we'll move to the problem number B in that same umbrella of 45. So if A is to B is equal to C is to D, so that means A is to B in proportion to C is to D, then find then a square plus b square divided by c square plus d square is how much? Okay, so you have to find the value of it. So let us start the problem. So now if these ratios are same, similarly we can take these ratios are equal to some constant k. This kind of method of solution is easier to convert the variables in terms of other variables, where I can say that a and b could be variables because their ratios are same for other values of a. So c could be another value of a and d could be the other value of b, some multiple or some lesser multiple values. So then a, if I equalize this, a can be written as bk and c can be written as dk. So there I can represent one variable in terms of other variable. There also I can do the same. So now if I put a square plus b square, and this we have to find the value. So if I put a as b square and k square, because a is equal to bk, so a square is equal to b square plus k square, and here already b square is there. This is c means d square k square plus d square. Okay, so now this is equal to, if I take b square common, this is k square plus 1, and if I take d square as common, this is k square plus 1. So now this can be cancelled, this cannot be 0 because this is square, that means it's a positive term. So this remains as b square by d square. Okay. So now this can also be said to be a square by c square. This also can be possible for this. So your answer for this has to be the ratio between b square plus by d square. Okay. Any other way of representing? No. This is the only possible representation. This could be b square by d square. Okay. So this can also be done in another way also, because these terms are given. So we know the a or b. So if I divide with b square both the terms, and this b have taken, so b square will go out, and here if I divide with d square, this can be d square c square by d square plus 1. Now this term is equal to the ratio, this and these are same, so this can be cancelled out, as because a by b is equal to c by d, so remaining is b square by d square. This also a possibility by doing that, but instead of that, if you do, there is no chance of this manipulation. You have to make it such a way that you can get the ratios equal. Okay, this need some practices, but this is the straightforward method. You need not to think so much. Okay, so the next is problem number C. Problem number C. If 6x square plus 6y square is equal to 13xy, find x is to y. Okay, so now this is a combination of quadratic equation, some kind of second order equation, to some ratio and proportion. This is a combination of these two, as because you can see this order is 2, here is also order is 2, this 2, so this is a second order. So how will you solve it? So first thing you have to understand, x is to y means you have to find something x by y. So in this equation, by seeing this equation, if I can represent this in terms of some equation which will uniformly can be written as a quadratic equation of x by y, by seeing that that is possible, what you will do, you have to divide it by y square. All the terms you have to divide with y square. So this will convert into 1, y square by y square. Here 13, and if I divide with y square, so y will cancel, so this will remain as x by y. So now see, everything, instead of writing it, so I can assume this is a, let be. So this can be a square plus 6 is equal to 13a. So this you can say this has converted into some quadratic equation of a variable a. So this is something like that. So now what could be the value of a? If it is possible to do in one shot, the factorization is okay. Otherwise you have to put formula. What is that? The value of a, the roots are minus b, so that means this will be plus, b is this term along with the first order. So this is minus b plus minus square root of b square, that means 13 square 169, minus 4 into a into c 36 by 2 into 6. So this is 13 plus minus 169, and this is how much? 4, 24, 12, 144. So how much it is? 25. So this is 169 minus 25 by 12. So this is 13 plus minus 169 minus 20, sorry, this is 144. This is coming 25. So 25 square root means 5 by 12. So now see, the value of a comes, if I take plus, this will be 13 plus 5 by 12 or 13 minus 5 by 12. So what are the values? 18 by 12, that means is equal to 3 by 2. And the second one, minus 13 minus 5 is 8. 8 by 12, that means 2 by 3. So these are the two values of a is coming. So that means if I remove all this, because values is only on the important. So what we have taken, there are two values are coming for x and y. So x and y have taken a, and that is coming as 3 by 2 or 2 by 3. Okay. So now in this equation, the value of x and y can be interchanged to satisfy the equation. Either you take x is equal to y or y is equal to x. This equation doesn't change its form. So this is very much symmetrical equation. So either you take this value or this value, so the thing will be same. So both are possible. So x by y is equal to a taken. So x is to y, it can be 3 is to 2. or x is to y, that can be 2 is to 3. Okay. So this is will be an answer. Fine. Now we'll move to the problem number D. Under 45. If P varies as R and Q and Q varies as R, P varies as R and Q varies as R, then which of the following, then which are the following? There are 4 statements. I will write those statements. Following are which of the following is feasible or possible, or which are the following, because any of the 4 options you have to choose, so following is possible. Okay, so let me write the conditions. The first condition is says P plus Q varies R, whether I can write this, or P minus Q varies R 1 by R, sorry, given 1 by R 3 root PQ varies R, 4 is PQ varies R square. So now see, from the option you can directly say that this option and this option are same, because under root of PQ varies with R. If I say the varies PQ varies with R, so if I square it up, the PQ varies R square is a straightforward relation. So if it is true, this also to be true. So from that, we'll leave this 2 alone. The first thing is that if you have to eliminate, so and there is one option is possible, so you definitely neglect this, because these are the same thing I am telling. So now P varies with R, Q varies with R. These are all varies with R. Okay. So, but from these two, what are this implies? P could be a constant K1 with R, and this Q, if it is constant, I can take another constant with R. Now from this two, if I add this P plus Q, R can taken common and K1 plus K2 is another constant. So now from there we can say that P plus Q varies R. This is possible. This is possible. Let me deduct it. So this will be K minus this K2. So this also for P minus Q, if I take, is proportional to R. This is not the right answer. This cannot be right answer, because this is saying this is 1 by reverse of R, but whereas P minus Q is proportional to R. So this is not the possible answer. Now if I multiply this two, PQ is equal to K1 K2 into R square. So now P1 P2 is equal to K1 K2 R square. This is also a constant. These are, so PQ could be possibly proportional to this, also true. So now if I square it up here itself. So now this also under square of k1 k2 also constant, so this is also possible. So there are multiple answers that is possible, only not possible. So let me check what they have asked. This is not feasible. Oh, I have written it wrong. Which are which is which is which is which of the following is not possible actually. I have written somewhat wrong here. So because out of this all four, this option are okay. This is straightforward wrong, because that I can prove that P minus Q is proportional to R. So that option, this is not correct, and the question I have taken from somewhere, missed to write not possible. This is not possible. So our option has to be 1. So definitely the question must be not possible. So this will be the correct answer. Okay. So I move on to the next problem. That is problem number E under this, and this will be the last. The next problem comes is E under 45, and this is your last problem in this serial, and it says if A and B are positive integers, A and B are positive integers, then root 2 always lies between, there are 4 options being given. A is A plus B by A minus B and AB. Option B is given as AB by A by B to A plus 2B, A plus B. C is A and B, and D is AB by A plus B and A minus B by AB. So these are the 4 options given. So when you have to pick the option, so we cannot much do with the options given, because these are given in A by B, and whereas this is the value. So one thing we know, the root 2 value is 1.414. Okay, so this you can take lies between 2 and 1. Okay, so this, so now putting any arbitrary value of A and B, let it be where A greater than B. If I take A greater than B, if I take the range A and B as 2 and 1, so now in this we have to check the options. So if I check the first options, this is 2 plus 1 3, and it is 2 minus 1 3, so this is 3 and this is 2. So this cannot be checked. Second option, 2 by 1 is 2, and the second option is 2 plus 2 4 and 3, 4 by 3. So 4 by 3 is approximately 1.313, 1.33. So this could be an option. So option B is okay. Option C is A B, so 2 and 1. This is also correct for this set of value, 2 and 1 for this set of value. And D, if I check, 2 into 1 2, 2 plus 1 2 by 3, and this is 2 minus 1 and 2 half. So this could not be option. So in the first set of value, this 2 are possible, B and C. So in next set of value, because we are doing trial, so next integers we are taking lesser value so that the calculation will be easy. And 2 by 3, and we will check these 2 options only. In 2 by 3 you will see the range becomes 2 and 3, but whereas this is value 1.414. So this also eliminated for the second set of value. The only option possible, this definite, because all 3 are obsoleted, this must be an option. So let me cross check also. So definitely you will get the answer. 3 by 2, this is one range, and that is 1.5, and this is 3 plus 7, 3 plus 4 plus 7, that means 7 and 5. So 7, 5 is approximately how much? 1.2. Yes, so 1.2 and 1.5, this is carrying this value. This is in between these two range. So this is always true for any set of value. Okay. So for your further clarification, you can take where B greater than A, and you can try. But where you are obsoleting all three, so you are having one options only. So this is definitely be answer. Okay. So this is one thing. But in case it has said that you have to prove it, but sometimes it definitely comes directly. This is very specific problem where you have to prove it. You have to prove it if this is there, the lies between this. So now this being pretty tricky. So that I am going to show you how to do it. So that if I will start with taking the value subtracted. Okay. So now what is the LC will be this one. So now you have to multiply this minus AB and this 2B square. So this will cancel, A square minus 2B square. Now why I am doing this? Because this minus this, if it is greater than 0, that means this will be the higher range, this will be the lower range, and the root 2 has to be proved between this and this range. This could also be possible less than 0, and then the range will revert, and then your target is to prove accordingly this value is less than this and this is higher. So accordingly, now this value, that the hierarchy means the greater than 0 less than 0 depends on this total value. Now this is an integer, this value is always greater than 0. Okay, now only option is this will decide your sign. If it is negative means less than 0, this will be less than 0, this is greater than 0, this will be. So now if I take the first case, A square minus 2B square for any value of AB is greater than 0. Let me take it. So A square greater than 2B square, where A greater than 2B, because I am just square rooting, and it will not change sign until if I take here the condition I have taken A greater than B. So when I do square root, there will be two values, A plus and minus. So in that I will take plus because A greater than B I have taken. Okay, so this will sustain A greater than 2B, where A greater than B I have taken. Okay, so root 2B. Fine. So now from here A by B greater than root 2. The first condition I have got. Okay, if it is 2, so this the first range is that A by B, because this has to be one part. So A by B, what I am getting, it is greater than 2. So the higher range I have already got. So now this has to be proved it is more than this. Now for that I have to come from this part. Okay, so what I will do, I will add A square. I am further adding another A square. So A square plus 2B square. So this become 2A square. 2A square. Okay, fine. So now so if I add further 2B square, this will be added, because if I do the same operation both sides, this inequity won't change. So there I am doing, first I have added A square, here I have added square, so sign will not change. Here I am adding 2B square. This is because to bring the equation to the required form. Now I am adding how much? 4AB I am adding. So there A square plus 4B square plus 4AB also I am adding. So this will I will take 2 common, so a plus b whole square greater than here a plus 2b whole square, a square plus 2 into a into 2b plus 2b whole square, so a plus b whole square. So this become now 2 I take one side, I will divide with a plus b whole square. So I am doing the same operation, so a plus 2b by a plus b whole square. Now take a root of that, so this is square root and this will become, now see root 2 is greater than this, so my lower range I found. So this can be proved the root 2 is in between this. Now similarly in this case I have assumed this this is less than this is greater than 0. For that this is greater than 0. Now this, if it is greater than 0, for this also to be greater than 0. So now how can I pretend out of this which one is higher? So now if it is greater than 0, you can say a by b greater than a plus b to be a plus b. So that means this also satisfies this condition, because root 2 itself is greater than less than this, greater than this. That will confirm that this is in between that. But that also a responsibility to check whether out of these two which one is greater. So that when I assume the first condition, a square greater than a square minus 2b square greater than 0, that confirming this one. So a by b is greater than this one. So this is the first case. In second case, similarly you can take less than 0, so this means this has to be less than 0 then, so this will be another. But from that similarly you have to prove, as I derived the same derivation, only then this sign will go as less than 0. So in that this range will revert, and that time also this will be the case you will find to be when you are taking a square minus 2b square is less than 0. The first condition is a square minus 2b square greater than 0. By taking that you have proved that. But if we take a square minus 2b square less than 0, you will get the reverse of the range, but this will remain in between this range. So I can prove that root 2 is always between this range, whether this is high, this is less, is respective, but this will always be inside this range. Okay, understood. So this is a specific problem that always come. They are changing the representation of the integers, but they do check this directly. Whereas the first part of that, where there is an option, you can put your set of values and you can check it easily. But whereas you have to prove it, that is a difficulty comes there. So just go through this. This is a very specific and a unique problem and very interesting problem too. Okay, so thank you for now. In the next video I'll move to the problem number 46 and the rest of the problems up to until 50 numbers. So thank you for now.